Okay, so today we are talking about how we describe things usefully. And what do I mean by usefully? I mean so that we are all agreeing on a common set of facts. So for example, how would you describe this color over here to make sure that someone exactly copied it? Would you say that it's perhaps grayish blue? But like, what exactly does that mean? How do you get it exactly right? Especially if it's from the infamous dress. Is it blue? Is it white and gold? The world may never know. So, what we're talking about today is useful ways to describe things and how we convert between those different features that we can actually measure. And this is all in Learning Target 1.1. We're going to be talking about dimensional analysis, also known as unit conversion. And we'll talk about conversion factors, and those are the things that help you get between units. Now, keep in mind, these learning targets, you do not have to memorize them. They are always going to be in the chemistry learning targets.in Schoology. If it's not uploaded by the time you see this, feel free to remind me. You also are going to have it on a Google Doc later. So, this is what we're talking about. Let's get to it. Now, another tool we're using in this class is something called OneNote. This is basically going to be an interactive notebook, which is where I can give you things. You can start working or writing on things. So let's get this set up. Now your first step, I need you to open your browser and go to office.com. Then you're going to log in with your Microsoft account. Now, odds are good you have forgotten what that is. That's okay. Log in with your school email and what you think your usual Carondelet password is. And feel free to pause this video as you do this stuff. I'm just going to keep talking. Okay, the next step, once you're in Office, you should have a screen that looks roughly like this with this lovely menu of apps on the left. You are going to click on the one that says OneNote. That should bring up a list of notebooks, probably just one. If you don't see one under Recent, that's because you haven't opened it yet. You can click on My Notebooks or Class Notebooks. Either one should get you to see something that looks like this. One that says Chem 2223, period, and then whatever period number you are, 2, 5, or 6. Keep in mind, if you just transferred in pretty recently, I'll need to manually add you. So this is the point when you want to raise your hand and say, hey, I'm not seeing this notebook. Can you help me? Once you open up the notebook, you're going to see a number of folders in there, but you're also going to see towards the top of the screen, probably towards the right-hand side, something that says Open in App. And this is for, regardless of what device you're working on, this is going to open up this class notebook inside the OneNote app. Unfortunately, the first time you can't actually access it directly from OneNote. It's a bug. You have to go through Office to teach it where to look for it. But after you set this up, you won't have to do this every single time. So now that you have it opened up, hopefully in the app, this is the content library. Now, the content library here is basically the equivalent of My Master Documents. So it's a filing cabinet that you can copy stuff out of, but you can't actually write on it. So if you're ever trying to write on these and you're like, I can't edit it, it's probably because you're in the content library. So you need to make yourself a copy. So inside Content Library, you'll see a folder that says Unit 1 Building Blocks. Click on that. And then you will find the document 815 Dimensional Analysis. Click on that and you should see something that looks like this. So over here on the right-hand side, you're going to right-click, or if you're on an iPad, hold down to pull up a menu. Then you're going to select Move or Copy and select the folder with your name on it to copy it to your personal folder. And again, if you're having trouble with this, this is the part where you raise your hand and I come over to help you because this part's a little tricky for me to demonstrate. So now that you have those guided notes available, keep in mind these are totally optional, but this is a way to help you organize your information. You can also go ahead and manually write it in that notebook you picked up last time. So today we're talking about how to describe things. Why? Because science is a systematic way of building and organizing information about our universe. So we need to have it systematic so that we can all agree on what things are and how we're describing them. So for example, let's look at this African elephant. So we can look at a bunch of different types of information that we can get from this African elephant. For example, we can talk about how much space this African elephant is taking up. That's called the volume. For example, the average blood volume of an African elephant is 245 liters. That is a ton of space. The African elephant also has a lot of mass. So not only is it taking up a lot of space, but there's a lot of matter or stuff in it. So the average mass of the African elephant is huge. We can also talk about how long the average African elephant is and how tall. That's going to be our length from end to end measurement. And finally, we can also talk about the temperature. What's the average body temperature of an African elephant? How hot or cold is it? So these are common things that we can talk about and we can easily measure in order to agree on what we're talking about. But there has to be consistency. So why does there have to be consistency? Because when there's not, we run into problems. So why do we care? If you want to watch this full video, it is available on Schoology for you in the form of an Edpuzzle. But the gist of it is that when NASA and another space agency were trying to work together on getting a space probe out, one was using imperial units, one was using metric, and that meant when they meshed the two systems together, they were off by a really important factor, which meant that the probe completely failed. And that was a really, really expensive error. Highly recommend, go watch the video, see why units matter. Now, what's the solution? The international community came up with a standard set of scientific units. These are mutually agreed upon units for each of those things that we talked about. Then, if you want to use another unit, there's a conversion factor to help you get from one to the other. So, for example, volume. The standard unit of volume is cubic meters. The standard unit of mass is kilograms. Standard unit of length is meters, and the standard temperature is Kelvin. So if you are following along in the guided notes, this is what you're going to write down for those units. But here's the thing. Those units aren't great for all occasions. So we have to be able to convert. What do I mean they're not great for all occasions? Isn't like a unit a unit? No. If we look at temperature, for example, Fahrenheit, which is what we tend to use here in the US, that is a really good way to describe what humans feel. So if we go from 0 to 100, 0 Fahrenheit is really, really cold for humans, and really, really hot for humans is 100 degrees Fahrenheit. But if we go to Celsius, this is describing what it feels like to water. So for water, 0 degrees Celsius is really, really cold, i.e. where it freezes. And 100 degrees Celsius is really, really hot because that's where water boils. But that's a super different experience for us humans. On 100 degrees Celsius, it's not just really, really hot. We are dead because the water in our body is boiling. And then Kelvin is talking about what does it feel like to an atom or a molecule. It's talking about that sort of scale. But 0 to 100 Kelvin, that's way too cold for us. We are super dead. We're going to talk about that conversion another time. So we have to be able to convert between different units in order to make these very helpful. We can't just say, oh, it's 100. Well, 100 Fahrenheit is very different from 100 Celsius, which is very different from 100 Kelvin. Now, you already do unit conversion all the time. And you don't even really notice it because these things you do without thinking. So, for example, if I say, how many eggs are there in 5 dozen eggs? I'm willing to bet you just said or thought 60. Without pulling out a pen or a pencil or any paper, you probably just know it. Well, here's the thing. That's because your brain did a shortcut. You know that there are 12 eggs in 1 dozen. So you know if you have 5 dozens, well, that must be 5 times that. And what I want you to notice here is that our dozens are canceling out. Notice this is a multiplication sign, not an equal sign. Do not put an equal sign here. So we are multiplying 5 dozen times 12 eggs per, that's what that line is, 1 dozen, which gets us 60 eggs. It's the same process. Now we're just slowing it down and looking at it carefully. Okay, what about 250 milliliters to liters? Well, in your head, you know that there are, hopefully you remember, there are 1,000 milliliters in 1 liter. Again, if you don't really remember those conversions, we're going to practice those tomorrow. But you know that there's a lot of little baby milliliters in 1 big liter. And so you do the conversion. The key to setting up unit conversion. Line up your conversion cancels to get units to cancel first. Then do your math. So, let's look at this example. My dad, that's actually my dad right there, makes 200 macarons per week. And he gets his eggs from his neighbor's 3 chickens. So how many eggs does each chicken need to lay if he uses 66 eggs to make 50 macarons? So, first, let's take a look at what conversion factors we have. So we said we've got 200 macarons. We know that it uses 6 eggs for 50 macarons, and we have 3 chickens. So how are we going to figure out how many eggs each chicken needs to lay? Well, we need to get eggs per chicken. So let's start with what we know. We know he makes 200 macarons. That's not a conversion factor, because there's no bottom part or top part. It's just a number. So we're going to start with that. And we're going to draw this here. This is called a railroad or fence post. And basically you put what you know at the beginning. And then at the end, these are the units we know we're trying to end with. Eggs per chicken. So how are we going to get those macarons to convert? Well, we got to look at our units. We need those macarons to cancel. So we're going to plug in 6 eggs per 50 macarons. Our macarons cancel. And we know we need chickens on the bottom, so we put 3 chickens down here. Then we do the math. 200 times 6 divided by 50 and 3. And that gives us 8 eggs per chicken. All right, now I want you to try it. Your car is traveling 30 miles per hour when you get a text. In the 5 seconds that it takes you to read that text, how many feet did you travel? Do me a favor, I want you to pause the video right here. Try it. All right, so we're going to start by looking at what our different conversion factors are. So we know our given is 5 seconds. We know that because there's no per anywhere. We have 30 miles per hour, which looks like this, 30 miles over 1 hour. We also know, because we got to get to seconds and feet somewhere in there, we know that we need to convert miles to feet. We've got seconds and minutes to hours. So how do we know where we put all this? Well, let's set up our fence post. Here's our fence post. We're starting with our known, 5 seconds. That's usually a good place to start since there's no per. And we need those seconds to cancel out because our final answer needs to be in feet. There's no seconds there anywhere. So, which thing has seconds? Nope. Aha! 60 seconds per minute. Oh wait, but if we just plug that in, we're going to have seconds times seconds, which doesn't cancel. That means we have to flip this. So we're going to flip it and plug it in. That way seconds cancel, and now we have minutes. Now we need minutes to cancel. Well, that's not this one. Oh, this one has minutes. Oh, but we got to get that on the bottom to get minutes to cancel out, and so on and so on. Plug it in. You should get 220 feet. So, Now I want you to go. You can watch a video in OneNote if you're stuck, or do the unit conversion practice in Google Forms.